Okay, so for those of you interested, I mentioned this last week sometime, or looks like fairly early in the week, last Monday, a week ago, about there's a thing going on campus today over in the business building. It's like an all-day thing. It starts like I think right now until 5, 6, 7 p.m. or something. Then you could sign up for it as a student. It's free. I doubt you probably need to sign up if you're only going to one session, but there happens to be a session from 4 to 5 p.m. from this guy named Jaron Lanier, who's somewhat of a long-term person in the tech industry dealing with VR and social media and stuff. And he's giving a talk at 4 p.m. today. The title is the role of social media in a civil society from Facebook to metaverse. I don't really know what it's going to cover, but sounds kind of interesting. And it's from a guy who's been in technology for a while. So if you are, I'll be there. So if you're around and want to pop over to the collaboratorium over by the Makerspace in the business building at 4 p.m. today, I think it would be worth your time to hear him speak. It's only supposed to be for an hour. Maybe he'll go less than that and take questions and answers, but it could be somewhat interesting. It could be a snooze fest too, but I don't anticipate that. I think at the very least, it should be an interesting thing. So if you're around, I encourage you to go there. I think a couple of us are going over to Highland House afterwards to debrief and talk about it. And you're invited if you'd like to join in on that as well. Okay, so that's the scoop with that guy. That's today at 4 p.m. I posted the code at the end of class last time. We were having some problems with the this particular interpreter. And I was trying to, so let me just kind of review what the issue is. And this is really when you're comparing an older language like C++ to more modern languages, Java, C#. This is one of the major issues that these more modern languages have fixed. And that's with classes that have codependencies. So in our case here, we have a situation where we have our town class reliant on roads and our road class reliant on towns. So you have these two classes that are reliant on each other, codependencies. How do we let them know about each other without creating an infinite loop of including one guy, including the header file of the other guy who includes the header file of the previous guy, includes the header file of the previous guy, and then you have just this loop forever. Depending on the version of your compiler you're working with, there are some pre-compile directives you can get. I was looking at if not defined last time, the IFNDEF, trying to get that to work. It ended up actually being a pretty modern approach to it that's pretty compatible with what we've done previously with prototyping functions. So when we've first looked at C++ and we had like our main, and we wrote some functions below main and didn't know about those, and you had to prototype them prior to main. This is the same thing. We're basically saying, look, we know the compiler is going to compile the road class. We know it's going to compile the town class. I don't need to give you implementation stuff here, but what I'm telling town here is there will be a class called road, so you can avoid screaming right here. Trust me, it'll be there when you go to run it. Similarly, over in road, same thing. Over here on road, I'm saying, look, there will be a class called town. I promise you, it's going to get read in somewhere at some point. So when you're compiling road here, don't freak out when you hit references the town there. All right. So it's actually a pretty modern approach to it. I just made the assumption it was going to be a much older, archaic approach. This is really the easiest way of handling codependencies, which get handled for you automatically in a language like Java, C#. Java and C#, you don't have to let a class know about any other class. As long as it's in the local package, you're just good to go. Put it in the same directory and it just knows about them. But in any case, that's the solution to the issue we're having right at the end of class last time, dealing with codependencies on these classes. So before I go any farther, are there any questions on that? Good. Not the order you write your classes in. The one thing I think you want to try to avoid, and you might see this if you go and if you ran into this problem doing your homework and went and looked at some Google solutions, I would say you don't want to get into the habit of like putting all your stuff inside of one class, because a lot of times that's the solution. You can just have all a class, and just everything's cool. Although you would still have this dependency problem in this case, because now it's a matter of, do I define road first or town first? You'd still have to prototype the other guy at the top. But in general, I would be an advocate of never having more than one class defined in a file. I do think for the modern developer, I mean, we're approaching this from a pretty traditional perspective, where every single class we create, we have a header file and we have a C++ file which implements that header file. I think you could probably, and the idea behind that is it becomes somewhat self-documenting. If I want to find out what can a road do, I can just dive into the header file, and this guy gives me a snapshot of what that guy does without having to fish through all the implementation stuff. Realistically, you could make an argument modernly, especially since we have compiler or interpreters now, like even this guy has it built in where I can hit that little arrow and it compresses that. I can do that in my other classes. So let's see that we probably have something in. Yeah, so for instance, for town, I can minimize display. I can minimize that. Effectively, I have the same thing as a header file right there, don't I? I mean, if you're just looking at it, I effectively have in my CPP file, I have, oh, we have a constructor and we have a function called display. The only thing I'm missing is this section right here, which you could put in the implementation. Nothing keeps you from doing that. So you could make a modern argument that if you're writing C++ code modernly, you could avoid the header files because our modern development tools have these little things built into them that allow you to quickly get a snapshot of what the code does rather than keeping them separate. Keep in mind, this idea of header files was something from a long time ago when we didn't have graphic user interfaces. This was when everybody was writing with like a VI text editor, where you didn't have a little button you can click to minimize a function and only look at the header. You had to fish through the walls of text. So header files they really solved the problem. We'll keep going with header files here because I do think it's an important concept, let's say, to practice, but more importantly, because you still have to use them sometimes. I mean, think about when we have like our main here, we are, including other header files. If we want to do some IO stuff, like I think I did in town, we had to bring in IO stream, we had to bring in string. These are things that exist external to us. So this idea of bringing in header files is still a thing, but you even see us evolving outside of that a little bit here. So historically, you would have included iostream.h, but now you don't do that. Now you just include iostream, and it's found inside of namespace standard. So we've even seen the syntax evolve over the years. But if you go back and you use some relatively old C libraries, you will still include something.h. This is a reality because C's been around for a long time, and a lot of these libraries are still good. I mean, a lot of them are for doing mathy type stuff, sine, cosine, absolute values, that kind of junk, square roots. These things are built in. There's libraries for all that, and chances are the library that was built day 2 of C++ in the late 60s probably still fine today for calculating the square root. Why reinvent the wheel? Okay. Questions about any of that, but your core question there is, does it matter the order? Should you ever worry about the order of classes? I would say no, but always keep them in separate files. Even if you're going to define the class and the header inside of a single file, have them in individual files, just like you would do in Java. Even though Java lets you define, you can have all your classes inside of one big old file, like you would have done in Python when you took the 200 class. I think all of you had the Python, or at least the guys who took 200 here. We did Python, but Python certainly supports having your stuff in other files. We just kind of, in 200, try to make it easy, keep everything self-contained. But now, as the projects you're working on get bigger and bigger and bigger, the idea of having your code a little bit more organized starts making more and more sense. Okay, so in any case, we have our towns built in terms of roads, our roads built in terms of towns. We solved this by having our little prototype thing there, just saying, compiler, trust me, you're going to have a guy named this. So then going back to my keynote here, what we are accomplishing is we want to build all of these towns. All right, I think I built Grafton already, so let's just build the rest of our towns. So we'll have Mequon, Cedarburg. We got 1, 2, 3, 4. Saukville, Fredonia, Belgium. Okay, so now we have all of our towns there. We'll just randomly test one of them here. Make sure that Saukville works. So there's our Saukville town. All right, so we have instantiated all of our towns that are part of our map here. Now we need to create our roads that lead between towns. And as a reminder, when we're building a road, it's going to take in the 2 towns that it connects, as well as the distance. Now, if I go back and look at my map, this road right here involves Grafton, and this road right here involves Grafton. Grafton still only exists one time. I've already created my towns. Now I'm going to construct roads between those towns. All right. So let's just start at the top here. So we're going to create a road between Fredonia and Belgium that has a distance of 6. All right, let's go back to main here. So I'm going to include road HPP. So I'll create a road pointer. And we'll just call this guy R1. I'll just name my roads R1, R2, R3. And this guy is going to be a new road between Belgium and Fredonia with a distance of 6. That's this guy right here. I just built this road right here between Belgium and Fredonia. Now I'm going to do Fredonia and Saukville, Fredonia and Port Washington. Steal that guy. Here's our R2. 5, right? Fredonia, Saukville 5, Fredonia, Saukville 5, R3 will be Belgium, Port Washington 8. Okay. R4 will be Saukville to Port Washington. We never gave a number to that. Well, we give it like a 3. We're close. Saukville to Port Washington. That guy a 3. I'm just going to update my map here just to show that road since I never labeled it. Okay, then we're going to do Saukville to Grafton 8. Those are 8. Then we're going to have Port Washington to Grafton 7. Okay. And then we'll have Grafton to Cedarburg 4. Okay. Grafton to Mequon 10. And lastly, Cedarburg to Mequon 8. Okay. So that is our graph. We had our 2 objects that are built in terms of each other, and we connected them all up. Now, one thing we might say is that in its current state, this was, I mean, it was copying and pasting for a map this size. This wasn't the end of the world, but this started getting a little tedious, right? What's the solution to things like this when you have a whole bunch of data that you need to convert into objects? And this was pretty much plug and chug, right? Wasn't every single thing I did the same kind of thing? Here's my town name. Here's another town name. Here's another town name. Here's another town name. And then here's a road that connects these 2 towns. Here's a road that connects these 2 towns. Here's a road that connects these 2 towns. All those things were the same. So what would be a viable solution to this kind of problem if, let's say, we were dealing with a map of the entire United States with a lot more towns and a lot more roads? We probably would not want to have a main with a zillion things in it, right? How would we solve that? What would be a viable solution to that problem where we still need to build our objects, but I probably don't want to just have a zillion independent instances inside of main? What do you think? Okay, you could have a loop, or so what would your loop have in it? Okay, sure. So maybe you start off with you know, an array of all the town names, and then loop through it and build those towns and put them somewhere. Maybe you have a collection of towns, something like that. If you want to take it even more abstract, you could say, well, I'm still going to have a loop, but maybe I'll put the data dealing with my towns in its own text file. or its own database, or maybe it's a JSON file I downloaded off the internet, whatever it is. But I have my data represented in one place. And then I have my code reading from that data, parsing it and doing something with it in another place. Does that make some sense? So I'm actually interested in, let's just do a quick test to see how file IO ends up working on online GDB. I think it'll probably work fine. We're just going to read in from a file with our F stream. It's to reading from it. Okay, this is kind of the guy I want. So there's our loop. I'll just grab this code and throw it in here for now. And I need to bring an F stream. Then we'll talk through it. Realistically, modernly, what we would probably do is we would probably read in from some database somewhere, or we would read in from a source on the internet. But nothing says we can't have our own local file system. So I'll actually go ahead and put this up top. I will go ahead and include F stream. That is what it's using, right? F stream. Yep. And then I need my namespace standard because that guy's living there. And I'll probably also put IO stream in there since I want to be able to prove that I wrote something in. So it'll have IO stream using namespace standard. I'm working with strings here, so I'm also going to need to include string. Okay. So inside main, and what I'm going to do here is I'm going to just create a file that has my city names in it. So I'm going to create a new file here. So we'll call this guy cities.txt. You can name it whatever you want. You can name it cities.dat if you want. So maybe it's your city data. Whatever you want to call it. That extension doesn't really matter. I'll leave this txt. All right. And then inside this file, I'm just going to list my towns. So we'll have Mequon. We'll have Grafton, Cedarburg, Saukville, Fort Washington, Fredonia, and Belgium. Did I cover all of them? 7 of those dudes. 1, 2, 3, 4, 5, 6, 7. Okay, so those are my towns. All right, and they're inside of a file here called cities.txt. So now in main here, I'm going to go ahead and create a string. The string is going to be used to read in stuff from my file. I'll store it in a string and then I can do something with it. All right. Then I'm going to have an input file stream. And my file here is going to be called cities.txt. I'm telling it, and this is where I'm interested in see how online GDB handles this, because effectively I'm saying, look in the current directory for a file called cities.txt. I think this will probably work. Okay. Then I'm asking a question. I'm asking, is the file that I just tried to create a stream from, is it open? Did I find it successfully? If yes, I'm going to do some stuff. What am I going to do? Here's a function called Getline. I'm going to ask you some questions about this, even though I'm assuming most of you haven't seen this before. So Getline is a function. I'm passing it two things. what kind of animal is my file? What kind of variable, what variable type is my file? It's not rocket science, right? I'm using the variable here. It's defined right here. So its type is an IF stream, right? What kind of value is line? String. All right. So now Getline, what kind of animal is that? Cat, dog, or function? Function, right? So this is a function that takes two parameters. It's taking in an F stream and it's taking in a string. Now, presumably, after when Getline reads something in, it is putting into line the next thing it read from my file. Notice it's not returning a value. I'm not saying something like line is equal to Getline my file. That might be something that would be pretty common for us to see in maybe a modern language, like in a Java or something. We might say, oh, well, I have a file that knows how to read something in, and it's going to spit out the thing it read in, and I'm going to store it in a variable. So this would be a pretty common way we might recognize it, right? But notice here that the syntax for this guy doesn't actually return anything. Getline is a void function. But after this function got called, line will hold a value. What does that tell you about line here? And really, it reaffirms this idea. Line is a string, which is an object type, right? Now, by default, are objects passed by value or by reference? Or by address? Reference, address, same thing. When I pass in line here, that variable is what we're doing is we're passing in the address where that string is in memory. So inside of Getline, it's going to do its magic of reading something in from a file, and it's going to go ahead and load into memory the thing it read in. It doesn't have to return it. It already put the answer inside of line in memory. So when I come out here and I try to print out the value in line, it's going to print out the actual line, the thing it read in. And I'll use our newer style Endel thing here. Wouldn't have made a difference if they do the same thing. All right, does that make sense? So this is kind of a common way that some older style functions work in C and C++. This is an old C function. So it's common for you to pass in your parameters and have it go ahead and update those values in those parameters, whichever one it needed to change, rather than spitting out a result. Or typically, when we think about writing functions today, we're thinking about a function having a return type. Here's what you need to work, do your job, spit out the result. Make some sense? All right, so this is a format for functions that is common in older code. And this is stuff that isn't necessarily, this is stuff that's still found in industry. That's kind of why I want to show this to you like this. This isn't like old antiquated stuff that you'll never see again. It's important that you're able to see something like this and understand it. And let's see if I go back to the documentation we were just looking at here. I think it showed function names. So it'll show us our Getline somewhere. I just want to bring up the documentation for Getline. Just so you can see what it's taking in. This is Microsoft's documentation, maybe. That's not what I wanted you to open. Why wouldn't you open the local terminal first? And then I followed it up with opening Ubuntu's terminal. Well, fine. We're going to use this one. So if I do man Getline, so we want to do this from fstream. Does it show me the fstream one? No, it's just showing me a newer version of it. But it's kind of a similar type thing. This one actually does return a value, but notice it doesn't return the string. This guy returns in how much it read. So in this get line, you're passing in, this is a string, but it's a pointer. So this is a char pointer, which is the same thing as a string. So this is a pointer to a char pointer, which would be the base address of a string. And then I'm saying, try to read in this many bytes. And you're reading it in from this file. So the result of this will be to read from this file a maximum of this number of bytes, and it will load the answer into this string. It happens to, in this case, return the number of bytes that it actually read in. Just in case you said, read in 100 bytes, but I only read in 30. That's what I was able to get for you because I ran out of stuff in the file, something like that. Right, but this is a common way that functions have worked for years and years and years and years. Suspend this one. Looks like Windows is still suspended, so I lucked out there. Just out of curiosity, let's see if this guy shows an older Getline. Yeah, same thing. Because fstream is an even older library, but same diff. Okay, or Getline rather. Yeah, fstream's an older library, so Getline is from that. All right, so understand what this does. And this while loop says, as long as this guy did something, as long as it got something other than null, if it did its job, then output what it read in. Do that until it runs out of crap to read in. What Getline likely does is when it reads in the very last, the end of a file, which is usually EOF, end of file, that'll boil down to a 0, a false, which will cause this while loop to end. And then we will close our file. So if this works out, we should see the contents of our file spit out to the screen. I'll get rid of my sock fill display just so that stuff is all built up there. Now this else here, I'm going to write this in a little bit better format because I advertise that it's never wrong to use curly braces. So this says if your file was successfully opened, that's what this guy tries to do, then do this stuff. Otherwise, we're going to output something bad happened. We couldn't get your file opened. All right, let's see if this guy can read in from that file. Yep, it did. So there's the contents of my file, read in. Okay. Now we could say, you know what? So this kind of goes down the same path as kind of this historical idea. If I was dealing with a built-in linked list type or a vector or something like that, where it didn't matter how many elements we were reading in, then I could just create a blank linked list capable of holding strings, add my cities to it as I filled it up, right? And then, you know, if I read in 20 cities, I read in 20 cities. If I read in one city, I read in one city. Doesn't matter. But if I'm dealing with traditional arrays, I need to keep track of the actual number of elements that are, I need to pre-build that array for the right size. That makes some sense? So one thing I could do, so this is kind of looking at it from a hack perspective. I could say, if you put yourself back in the shoes of a developer from the 70s or early 80s, something like that, you might go into cities and say, you know what I'm going to do here is I have 7 towns here. I'll just put a 7 as the very first line of my file. That's the number of cities you're going to read in, something along those lines. Because now I need to make this file compatible with my code. All right, so I'll have on the very first line there that I have this number 7. I'll go back into my code here. So now if I'm inside of this if statement, that means it was able to read in my file. So I'm going to go ahead and I'm going to read in my number of. So I'll read once. I'm just going to assume that I do have at least one line, right? So I'll read in my get line, and that just read in line there. And I'll go ahead and do a cout line and del. And for right now, I'll just comment out that stuff. So I'm just reading in the very first line, loading it into my variable line, and then I'm going to output it. So this should show me my 7. There's my 7. But it read that 7 in as a string. What if I want that string as an integer? Because I need to know from that 7, I need to know how big of an array do I need to create, right? So I need to turn that string into an int, kind of like our integer.parseint from Java. So this is probably a to I think is the name of the function. Anything, it's not any special library. Yeah, it's in standard lib. So inside of a library here called standard lib, so we'll include standard lib. He's got chicken tenders and burritos. Good lunch. So standard lib, we have built-in functions, just like in Java, we would import java.util. And in java.util, we would have, actually java.util doesn't do it. The integer class in Java has the Parseint method that knows how to convert a string into an int. In here, we'll go ahead and I'll just say a to I of line. Make sure we still get our answer. It is standard lib.h. Yeah, it needs a basic string, not a new style string. So let's see if there's a converter. So this a to I is a much older function. He's taking an old style string. I probably could actually force it here. I could probably come in here and say, you know what? Go ahead and treat this guy as a char pointer. Let's see if he'll do that for us. Yeah, it won't let me cast it. He probably can let me go the other direction, but not this direction. So we need to do C++ string to int. So we're looking for the standard string to an int. Must have another function built into it. String to C string. So we can do that. So rather than converting this guy to a char pointer, we're going to say take my real string line, convert it to an old style C string, and then convert that guy to an int. And there's my 7. But now we know that this guy, I could add 4 to it. Might need to put that in parentheses. No, could add 4 to it. Now I know it's a number, right? I did math with it. All right, so what all went down here? I used a bunch of libraries. So I said, okay, read in my string, that's the number 7. I'm reading it in with a modern day C string, or a modern day string. I then need to convert it to an old style C string, and it just so happens that our modern day string has a function built into it called C_str that says, hey, I'm a modern day string, but if you need an old school version of me, here it is. All right, so this will boil down to an old school version of whatever's currently in line, which happens to be the kind of thing that A2I takes in as a parameter. So this guy right here boils down to the integer version of the old school string stored in the new school string line. And then I proved it's actually a number now by just adding 4 to it. All right, makes some sense. So now, since I proved that works, I can now create a variable int number of towns is equal to that. So now I have my number of towns. We out at 50 or 55? 55, right? Okay. So I have my number of towns inside this variable called number of towns. All right, so now I need to go ahead and create an array to hold my towns. So I'm going to go ahead and I'm going to create a town pointer. Call this guy array of towns is equal to malloc number of towns times size of town pointer there. Make sure it's cool with that syntax. And then I need to say this guy's returning a town pointer. I'll explain this in a second. Okay, so we're fine. Now I want to show you 2 versions of this line. So we're going to say I want a town so this line looks way scarier than this line, right? But they don't actually do the identical thing. The reality is this line right here would actually be okay for this particular problem we're solving. But the difference here is that in this case, I'm creating we know arrays are stored in contiguous memory, right? So I'm saying I'm going to create a variable capable of holding the address of a single town. It just is going to happen to be the base address of a whole bunch of towns. But how do I ask the operating system for enough memory for a whole bunch of towns? Well, I call the memory allocate function, malloc. I go out here and I do man malloc. You see that malloc, where's my malloc? This guy right here, he takes in, you tell him the number of bytes that you need, and he gives you a void pointer to the number of bytes. Call that a generic pointer. Void pointer is a generic pointer to the beginning of those number of bytes. So what I'm doing right here is I'm saying, look, I need enough memory to hold this many town pointers, right? Because that's the number of towns I'm going to have. For every town, I'm going to create an instance of a town object and have a pointer that goes to it. Make sense? So I need to know how big is a town pointer, and I want number of towns of those. So I'm asking malloc to give me enough total memory for this, and it'll come out of here as a generic pointer, but I need it as a town pointer because I know when I start walking through this array, I want to take town pointer size steps through this array. Okay. So that's what this line ultimately accomplishes. This line will give me effectively the same thing. So we look at this and say, well, why would anybody in their right mind write that when you could write this? In this particular case, based on what we're going to do, nobody in their right mind would do that. But we want to understand the difference between these two lines. This line is me personally asking the operating system for some memory. And now I own that memory. I'm in charge of that memory. When before main ends, since I'm asking for it inside of main here, that memory is a mess that I should clean up. I should be responsible for cleaning up that memory. This guy, though, he'll create an array that is managed by the C++ runtime. He'll get the right amount of memory and all that stuff, but as soon as main ends, that guy will disappear. It's not going to be a problem for us right here, but if I wanted to pass my array of towns to another function, you're going to find out that when you go in there and that function ends, any changes you made will disappear because it was temporary memory. Whereas this is memory that will persist. I would make the argument that whenever you create an array in C or C++, take ownership of your memory and say, look, I need enough memory for this. If we were writing this in Java, we would say, I need a town array called an array of towns. This guy's going to be equal to a new town array of size number of towns. These two lines do the exact same thing. We're asking for the same amount of memory. All right, questions, comments, concerns about that stuff. We'll come back on Wednesday and we'll keep cooking with this. There is an assignment up already that's due on Wednesday. It doesn't deal with this stuff specifically. It actually deals with things that were missed on the midterm. So a couple of questions for you to practice related to things that were missed on the midterm, specifically that stuff where I say, assume you have a linked list or a stack, yada, yada, yada. Solve some problem using that. Don't modify how stacks work. Use the stack. Use the linked list. All right, make some sense? All right, I'll see everybody on Wednesday. And that assignment's already up on Blackboard.